Hello, this quick clip is designed to cover elimination and substitution reactions in alcohols, which are another type of reaction that alcohols can undergo. So first of all, let's get a couple of definitions down. It's worth making sure that you've gone to your definitions list and made sure you've got a flashcard for each of these. These are just general explanations I put on the screen to keep from using up too much space, but it's important that you make sure the definitions are down according to the textbook. So make sure your flashcard has the textbook definition on it. So now what we're going to do is have a look at each of the reactions in turn and show you an example. So when you look at elimination, if you're removing a water molecule from an alcohol, this automatically becomes a dehydration in addition to being called an elimination. So remember when we talked about these on the last slide, you can classify elimination reactions and dehydration reactions together. In other words, dehydration is a type of elimination. So if we take a cyclic alcohol such as cyclohexanol, and we react that with a concentrated strong acid such as phosphoric acid, that will give us a cycloalkene and water. So it's important to remember that the carbon-carbon double bond could occur here or here, provided it occurs where the OH group is attached. So these bonds on the cyclohexanol could become carbon-carbon double bonds when the reaction takes place. A couple of other key points to remember. So it's important to remember where the carbon-carbon bond will form, and also the fact that concentrated sulfuric acid could also be used. So now let's have a quick look at substitution reactions in alcohols. Generally, in AS or first year A level, what we're looking at here is the substitution of the OH group with halogen. Obviously, other groups could substitute as well, and they'd still be called substitution reactions. But the one that we particularly look at here is the creation of a halide ion, and then the substitution of the halogen onto the OH, onto the carbon chain, removing the OH. So I'm using propan-2-ol as my example, and hydrobromic acid is my source of bromide ions. Obviously, bromine is the halogen that's being substituted for the OH group in this case. So there's two steps to take. The first step is to create the HBr, and the second step is to then react it with the propan-2-ol. Of course, these equations can be combined by taking the reactants in each case and adding them all together, and the products in each case and adding them all together to give an overall equation. This can be found in your textbook, page 222.